Hey everybody, in this video we're going to solve linear and absolute value equations, but we're going to do it kind of interestingly. We're going to compare the graphs and how they relate to this equation. So right here is a linear equation, and that's because it has x to the first power. That's what makes it linear. And so we're going to look at is if we were to separate that equation into two functions. The left side of the equal sign is one function, the right side of the equal sign is another function. And how the graphs would give us this result that we're looking for, because we are looking for x. If I solve this equation, I want to know what is x. So let's graph the two functions. And the first one right here, this one is going to just be a line in slope-intercept form. So if you just rewrite f of x as y, you'll notice that this is just y equals 3x plus 2. And then you can tell pretty quickly two very important things about the graph. You can tell the y-intercept when you have this form. It's just the number in the back, so 0, 2. You can also tell really quickly the slope of your line. It's the number in front of x that's multiplying. So in this case, it's just 3, but I'm going to write it as a fraction. So we have 3 over 1. That way we can rise and run to get our graph. So we're going to plot our y-intercept 0, 2, and then use our slope to get to our next point. So we're going to rise 1, 2, 3, and run once to the right. And now we can do the same thing, or technically exactly the opposite of this to get more points. So from my original point, I'm going to drop 1, 2, 3, and run 1 to the left, and then that way I get more points on my graph. And so let's see if we can draw this straight line for our function, and there it is. So next, let's graph the line y. If you rewrite this, y equals 5. And so that one's really nice to draw, because y is 5 right here, but it's also 5 here and here and here and so on. So it is just a horizontal line anytime you just have y equals a number. And so the question is, well, where do these two functions intersect? Well, they meet right here at this point when x is 1. So they meet when x is 1. So let's see how we would get that from solving this equation. Anytime you're solving an equation, you're just trying to isolate x, get x alone. And so this way, you just undo what's happening. So we're going to subtract 2 from both sides, and then we have 3x equals 3, and then still I want x to be by itself. So if I divide by the 3 that's currently multiplying it, I get x equals 1. So x has been solved for, and we already knew that was the answer from our graph, but we lined it up with our algebra down here. And so that one is our answer for that linear equation. Okay, let's try this next one. We are going to be solving this linear equation, but we are going to graph the left and the right side of the equal sign as two separate functions. So the first one, this one's in a really nice format. They actually both are. On the first one, the y-intercept right here is 0, 3, and then the slope is 2, or 2 over 1. So let's plot that one pretty quick. So 0, 3, and then we're going to go up 2, 1, 2, and run 1. Because the slope is 2 over 1. And then let's just go from the original point down 1, 2, and run 1 to the left. All right, let me zoom in on that, make it look a little bit better. Okay, and let's do it one more time, actually. 1, 2, 1 to the left. Okay, and there is our first function representing the left side of our equal sign. And then the second one, we have a slope of 2/3 and a y-intercept of -1. So if we start at -1, 0, -1, we're going to rise 2 and run 3 to the right. So up 2, 1, 2, 3 to the right, and plot that point. Let's do it again. Up 1, 2, 3 to the right, and plot that point. And let's go from the original point down 2 and 3 to the left. Okay, and connect our points. And there is the right side of our equal sign, that function representing that. And so where do the functions intersect? Well, they meet right here. That looks like x is -3. And specifically, just so we are clear, there is a y value. It happens to be a -3 as well. But the question is about what is x. So x is -3 is our answer. So let's prove that using just solving this equation without the graph. So we already know the answer, but let's work through it. So this one's a little bit different because we have to get x on the same side of the equal sign in order to solve this. And so I'm just going to pick the left side. Move x over. by bringing all x terms on the same side of the equal sign. So I'm going to subtract the 2/3 x from the right and also subtract it from the left, bringing the x terms on the same side of the equal sign. Just to save some writing, let's go ahead and move the numbers to the right side. So I'm going to subtract 3 from the left side as well as the right side. So all that's left on the left side, all that remains, is a 2x minus 2/3 x, and the right side, it's going to be -1 minus 3 more. So this is -4. So now we have to combine these x terms, but you need a common denominator anytime you're working with a fraction and you're trying to add or subtract. So notice the denominator on the one x term is a 3. So if I multiply this first x term by 3/3, and remember you always have to multiply by the same number top and bottom because this is really like a funny looking number 1 right here, then we can have the same quantity, but it just is going to look better and we can combine it. So this is going to become 6x over 3 minus 2/3 x, and then that is going to simplify as 4x over 3 because we just subtract the numerators. The right side was still -4, and so there's really one more step left. You can break it into 2, but I'll show you how to just do it in 1. What's happening right now is your x is being multiplied by a 4/3. So if you multiply by the reciprocal, 3/4, you'll take care of everything affecting x right now. But whatever I do to the one side of my equal sign, I have to do to the other. So I have to multiply the right side by 3/4 as well. And when I multiply by the reciprocal, the 3's divide out and so do the 4's. And so what remains is that we just have x by itself on the left side, which is what we wanted. And on the right side, you can multiply this out right away if you want to. You can say that this is -12 on top and 4 on bottom. Or if you can tell that the 4's are going to divide out, but you're still going to have a negative, like a -1 right here, then you can just say that the answer is -3, which it is if you just divide -12 by 4. So that one is -3, which we had gotten from the graph. And so how can we find solutions to an equation by looking at the graph? Well, we talked about it. It's where the graphs intersect. If we make our equation to be two separate functions, the left side of the equation is one function and the right side of the equation is a second function. So in the next video, we'll continue this idea but using absolute value equations.